Orbital decay is quite simply just a fancy term for drag. So satellites have to move incredibly quickly in order to maintain a stable orbit around the Earth. They're moving very, very fast, and they encounter some small particles of gas from our atmosphere. Now this shot here shows the Earth's atmosphere. It's a very thin, incredibly thin and precious layer of gas trapped by the Earth's gravitational field, being held down by gravity, and it gets progressively thinner the higher that you go. So there's really no point where you're sort of inside and then you jump across that and you're outside the atmosphere. However, 100 kilometres is kind of considered around about the sort of nominal boundary. But at around about 120 kilometres, you're starting to notice those effects. So if you come in a spacecraft that's trying to re-enter the Earth's atmosphere, at around about 120 kilometres, you're going to really start to notice it. But it actually, even up to 150 kilometres or so, there still is quite significant amounts of atmospheric drag there. So for satellites in low Earth orbit, so these are the satellites used for GPS, taking photographs for Google Earth and those kind of things, they're around about somewhere between about 160 and 2,000 kilometres. So you want to keep them inside the Van Allen belts, but far enough out that orbital decay becomes less of an issue. However, there still is atmosphere there, and so those satellites suffer orbital decay. It's got nothing to do with how strong the Earth's gravity is. It's all to do simply with the drag with the atmosphere. And if we think about geostationary satellites at nearly 36,000 kilometres in altitude, at a very precise altitude, so they're going to orbit exactly the same period of the Earth, those guys are so far out that they really don't significantly encounter orbital decay. So really orbital decay is something that is peculiar to low Earth orbit satellites as they're close to the edge of the atmosphere. And it's worth saying that it's a positive feedback system. So as you encounter some orbital decay, so as you encounter some atmospheric particles and it starts to slow you down, the altitude is going to get less. And of course the atmosphere is more dense there, so you're going to slow down more, which is going to move you even lower down in the altitude, which means you're going to encounter more gas and particles. So it's this positive feedback system. So once orbital decay starts to set in and you start to lose altitude, you've either got to fire a rocket to boost your speed to get back up to the altitude you should be at, or that satellite is going to quickly decay away and end up burning up in the atmosphere, and perhaps fragments will end up being scattered in the ocean, which has happened with satellites that have lasted before. So orbital decay is all about drag.